Hi everyone, my name is Xiangyu Fu. I'm the co-founder and COO of Ownership Labs. Today, I'm here to help you get started with building applications on Dataverse OS. First, I'll tell you a bit about what Dataverse OS is, and then we'll go through some key conceptions of Dataverse OS to help you understand the system. Then I'd like to do a brief bounty description to talk about what the ideas that we want you guys to do during this hackathon. And last but not least, I want to walk you through a simple demo and some extra coding to show you how to start developing on Dataverse OS. So before all that, let me do a simple introduction to our team. Ownership Labs has been committed to solve the problem of data ownership with the help of blockchain technology for years. And recently, we reached a solution in the form of an operating system as Dataverse OS. So Dataverse OS is a Web3 native operating system with identity sovereignty and private data ownership. It is a secure cyberspace for users, and it provides programmable data layer for developers. So from my perspective, I'll define the Dataverse OS as a new kind of identity computer to visualize data files over dApps. This virtual computer consists of several parts. So firstly, we'll need the data wallet to sign into the operating system. Data wallet is a Chrome extension, and before we start developing, we need to make sure it's installed, and if some of you already have the data wallet installed, I highly recommend making sure it's updated to the latest version before we proceed with the development. Anyway, so we built Data Wallet as a gateway for users to Web3 dApps. It's a tool to help users store their DIDs and manage access to data resources. And for developers, it provides system calls that allow us to connect to a user's identity and obtain their signature permission, and then read and write data to their private data space. So here are some types of those system calls. In addition, the data wallet is responsible for preventing malicious applications from stealing a user's data with the help of dApp table, which I would like to talk more about later. So to help you get a better grasp of things, let me give you an analogy. It's kind of like you need a wallet address to send transactions on the blockchain, right? Like on Ethereum and every other blockchain actually. So that's why crypto wallets like MetaMask exist to help you manage your private keys safely. So in a similar vein, if you want to use the data operating system, you need a specific DID and a set of signing with Ethereum signatures. It's like having a secret code that gives you access to the system. So it makes sense to have a data wallet to keep all of these resources safe and sound. And secondly, I want to talk about the web native file system we built. It's a totally decentralized file system like the Finder on a Mac. So remember that secure cyberspace for everyone I just talked about earlier, where in Dataverse OS, all the data that users generate is saved in this file system, and it can only be accessed by users themselves with their permission. I believe many of you guys know that in the Unix philosophy, there's a saying like everything is a file. So it's not just documents or images. It's also all the stuff you create, your social connections, like your hobbies and your interests and your contributions to a DAO or whatever. So all of these will get collected and saved in this one place. Plus, we've got the SDK for developers to build all sorts of personalized services on top of this user's data space. So basically, this file system is like a super secure and programmable storage layer. It's totally isolated at the application level, but it's also interoperable. I'll show a specific user story as an example through the demo later. Okay, so in the next part, I want to talk about why we built this operating system and what makes it different from the traditional operating systems. But before we dive into the details, I would like to take a quick trip through the history of data to have some context here. So when I talk about data in this context, I'm referring to all the info that can be digitized and stored electronically. So at first, we got personal computers. We interact with softwares on our PC, and the data generated was stored in our hard disk. So at this stage, we actually had the control of our own data. But the thing is, it's not really easy for other people to access it. It's like we are all living in our own little data cubes, and there is no measure for sharing or making the data flow. Then came the internet, which totally changed the game. So suddenly data could flow freely between different devices, and we could access all the sorts of cool stuff online. However, this is also the beginning when we started losing control over our data because the centralization of this internet, because all the computing and storage happens in a centralized way. So in this stage, we've given up our data sovereignty in exchange for all the convenience of the internet. And now we look at Web3. So Web3 is the internet where data is computed and stored in a decentralized way. That's why we came up with Dataverse OS. I think it's the next generation personal computer, and it's decentralized, it's on the cloud, and it's self-controlled. Basically, we designed this system by replacing the traditional PC hardwares like CPU, memory, and hard disk with those decentralized infras such as blockchains, decentralized storage, and decentralized databases, and so on. So these infras can help us give back the complete control over data to users. The next generation personal computer is going to take the best of both the convenience of the cloud and the security and privacy of a local PC. So in summary, Dataverse OS will control and manage protocols like Ceramic and Lite to make it easier for developers to create all sorts of cool applications on top of these protocols. Okay, so let's now talk about the prices we are providing for HackFS. We are offering a total of $5,000 with $2,500 for the first place, $1,500 for the second place, and $1,000 for the third place. Note that any creative development based on Dataverse OS has a chance to win the prize. However, we have some suggestions that you can consider to increase the chances. So what do we want you to build during this hackathon is, first, explore the dApp, DAOs, social file, and AI use cases. Second is to integrate Dataverse Wallet to interact with Filecoin. And second is to create toolkits with other Web3 technology to demonstrate Dataverse OS composability. And here are some resources that can help you get started. Here is our website and GitHub, and Playground is a social application on Dataverse OS. Arado is a note-taking application similar to Medium, and we've also prepared a demo to show you how to use FEVM through our SDK. So welcome to join our developer channel for finding a team or asking questions. And you can check out our documentation at gitbook.dataverse-os.com. All right, let's jump into a quick demo of our system. It's already live, so you can check it out at dataverse-os.com. The demo will cover three main parts: the data wallet, the data desktop, and the ecosystem built on top of our SDK. So let's get started and see how it all works together. So first, the data wallet shows your token and data assets And below that, you can see which applications are currently connected to your identity. You can also manage multiple identities here. All right, let's dive into the system, sign in with the data wallet. And first is the user dashboard, which displays some statistics, and below that is dApp Launchpad. On the left side, there is a program doc similar to macOS. The first application here is our encrypted file system. Here you can create new folders, upload files, and so on. I'm sure you are already familiar with a file system, so I won't go into too much details. But I do want to point out that these files are organized by application level. For example, data from the playground application would be under the playground data space. You can see that there are two posts here that I created earlier. So let's create a new post in playground and see what would happen. So this is playground. It's a prototype of Web3 Twitter. Just post like hello HackFS message with, let's say, 2 pictures. All right, now it's created successfully. Let's go back to the file folder, and well, you can see that there is a new file here. The tweet that we just created was automatically saved in my file system, and let's monetize it with just one click. So set the price, the limitation, the number of copies, and choose which fields to encrypt. Okay, now we just need to wait for the transaction to be confirmed on the blockchain. This may take some time. Okay, it's done. Now let's go back to Playground and see what has changed. You can see that the tweet I just posted is now in an encrypted state in Playground because I chose to encrypt it while managing the file before. As the owner of this tweet, I can unlock it for free. However, if I switch to another account, I will have to pay the price to unlock the content. So here is the example. I just switched to another account. Need to approve the spending cap, send the transaction, and after the transaction is confirmed, now I have the access to this content. And here is another application on Dataverse called Arado. Arado is a note-taking tool where you can create nodes, save them to Dataverse OS, and share with each other. And personally, I love this application very much because I've been looking for a note-taking application that's both user-friendly and respects my privacy for a long time. So you can find the source code for both Playground and Arado on GitHub. Just search for Dataverse Playground or Arado and you should be able to find the repo easily. So before we dive into the technical part, I want to explain why Dataverse OS is a must. To put it simply, Dataverse OS brings security. The fact is that all the latest data networks are built on these two EIP standards, and these standards define how users can create identities, authenticate with applications, and manage data resources. However, it's worth noting that signing with Ethereum entirely relies on the signature. If some bad websites get the signature, users' data resources will be stolen. So it's us developers to take the duty of ensuring that user data can be safely stored and beyond the reach of other applications. Dataverse OS implements a new security layer to ensure that signing with Ethereum signatures are authorized to the correct application. How do we achieve this? First, each application has its own independent file system and the scope of data resources it can access. Secondly, users' data under an application will be encrypted before it's put in the file system. And thirdly, when an application asks for decrypting users' data, a sign-in with Ethereum signature must precisely match the scope of the application. Lastly, Database OS ensures that applications can only request sign-in with Ethereum signatures that only include valid resources, and the cross-application requests will be denied. So in summary, we protect the data security by building this signature to resources mechanism and keep the signatures safe. So this is a picture to show the composition of Database OS. It's actually pretty similar to modern operating systems, with layers like kernel, drivers, user interface, and system calls. The kernel is used to manage different Web3 protocols, and developers can interact with the kernel through system calls. The user interface can either be a wallet extension, or a browser, or a mobile application, or even a Linux distribution. So now let me give you a brief overview of the tech stacks behind Database OS, and hopefully give you a simple total view of how the system works. In general, our system integrates and coordinates many protocols. We have application layer protocols like Lens, storage layer like Ceramic and Fluence, access control layer like Lead, and infrastructure layer such as Ethereum and Filecoin. So the file system is able to hold all the files over all the applications by linking data streams on Ceramic. Every time a user creates a data stream, the operating system will automatically create a corresponding file stream and bind the data stream to the file stream and save it in the file system. The operating system adds access conditions to a file so that data or content can be shared and monetized. And let me explain by taking the example of posting a tweet in the playground. So the tweet is created on Ceramic Network as a data stream, and a file of this tweet will automatically be created in the file system. And we use Lead protocol to program an access control module for each stream. Thus, for each stream, the operating system generates a secret file key to encrypt the stream content and keep the key on Lead protocol's distributed network. So normally, only the data owner can obtain this key. And when we monetize a tweet, the operating system uses social protocols such as Lens protocol as an engine to turn off-chain data onto the chain, and then deploy a collection of NFTs. After that, the operating system updates the lead conditions to retrieve the file key. The NFT here acts as an unlocking certificate. So this means that only the holder of the NFT can obtain the file key on the lead network and unlock the stream content. By the way, I would like to emphasize that this picture here only describes the underlying protocols of the current OS. Database OS is highly open in its architecture, and we are incorporating more protocols into the system, such as ARWave, FEVM, and others. So we built a framework called Create Database App to help you guys create an application above the system, and we have the runtime connector JS library to help you integrate database into your projects. And in the next part, I'll show you how to use this by some coding. All right, now let's dive into some actual development stuff. I'm going to show you how to start building an application on Database operating system. And we've actually got a tool called Create Database App that could help. Just in the terminal, type npx create database app, followed by the name of your project, and this will create your project in the current directory. I would like to explain some directories here. The models directory is used to define the data structure in your application, in GraphQL format. So the three files in the FS directory are the data structures used by Dataverse file system. Besides, post and profile are examples we provide to help you you can create new models or make modifications as needed. For example, we can add a comments field in the post model. Next, we need to focus on the config. Here you will define some basic information about your application, such as the Slack. Slack is a unique identifier for every application. The name of application and the logo image. And for development and testing, you may set the website to localhost. You can also specify the default folder name, the description, and so on. And you can decide which data models to use. The is public domain field decides whether other applications can use your models, and the encryptable specifies which fields under the model can be encrypted. Since we just added the comments field, let's add it in this list as well. So in the testing environment, you can leave Ceramic URL as none. And you can also choose to deploy your own Ceramic node in production and fill in the URL here to use your own node. So lastly, you need to enter an Ethereum wallet private key in the env file. This private key will have, root privileges for this application. And here I will generate a new pair of private keys for one-time use to show. Okay, after all is ready, we shall run pnpm install, and after all dependencies are installed, just run pnpm create Dataverse app. So this will register your app to the dApp table and create those data models in Dataverse sandbox. Okay, successful. So before running the app, let's take a quick look at the app.json file in the output directory. This file contains all the information about your application, including the stream IDs of the data models you created. And running the application is simple, just run pnpm db and okay, so this page shows several key functions here, like you can connect to identity, and yeah, this is and you got a DID generated, and also create public content, create private content, and of course, we can create a data token by monetize our content. Great. As you can see, we are providing an SDK in the form of React hooks here. And these hooks are built on top of our runtime connector library. I hope it could make it easier for you to get started. And you can also use the runtime connector to access more advanced features. I'll show you how to use it later. So I would like to emphasize that we provide a sandbox environment for testing your application, However, when your application goes into production, we strongly recommend that you use your own deployed Ceramic node for storage. To help with this, we provide the dApp backend Git repo, as you can see here. Okay, this repo can help developers quickly deploy a Dataverse-gated Ceramic node. Another important point to note is that Dataverse OS doesn't control any data actually. If you choose to run your own Ceramic node, you can manage the data without the operating system. And this means that even if one day Dataverse operating system stops running, your application and the user's data will not be lost. You can always retrieve all the data directly using Lead and Ceramic. And after creating your application, you can add it to the dApp Launchpad on the Dataverse OS dashboard page so that you can do a testing here later. All right, last thing I want to show you is our developer documentation. The doc is at gitbook.dataverse-os.com. You'll see that we've got a whole section about APIs. There are 6 main categories as identity, app registry, stream, encryption and decryption, folder, and monetize. But before we dive into all these APIs, I suggest checking out the quick start guide first. It will take us from 0 to several most important core functions of runtime connector. So still you need the extension installed first. And you may use this command to install runtime connector in your project. The first thing to do is to connect with user identity. The example code is here and it's actually simple. Just use the runtime connector connect identity function. Okay. And creating public stream can also be done with one-line code. The example is here. So encrypting a stream can be a little bit more complex. First, we need to set up a set of decryption conditions for the lead network, and then we generate the lead file key, and then we use this file key to encrypt the content of the data stream. So basically, data monetization is a feature built on top of encryption. To monetize data, first we need to encrypt it. Then we use the create data token API to deploy an NFT smart contract on chain. After that, we may update the lead decryption conditions, set the NFT as an unlocking credential, and finally we update the data stream. So collecting a data token is rather simple. Just use the collect method and mint an NFT from the data token contract. And then we can, just load the stream, use the NFT to retrieve the file key on lead network as we just set it as an unlocking credential, right? And then I've got the file key, we could decrypt the stream content. Yeah, basically this is a brief overview of the core functions of our SDK. Hope you guys will try it out for yourself and explore more of the features and capabilities with this developer documentation. So all in all, Dataverse OS is a programmable data layer empowering super applications. It's a place for users to visualize their data values and a platform for developers to bootstrap their dApps easily. Okay, thanks a lot for tuning in. I hope this workshop can help you understand better of how Dataverse OS can help you securely manage and monetize your data. Hope you decide to develop using our SDK and check out our bounties and work on them. If you have any further questions, you can contact me on Dataverse's code. And yeah, hope you guys have fun hacking.